Now, before we start, I would like to ask you for a favor. Remember last time I asked about the possibility of using your personal Zoom meeting to record in case you don't have sufficient, well, equipment. And then at that time, I only know that for PhD students, they can record, but I don't know whether for master students, you can also record using your personal meeting room for Zoom. So can anyone who send me a private message about whether you also have well, the right to record your meeting? Now, of course, if you don't have such a need, then it's fine, right? And also today, get prepared, all right? So my lecture notes is released 1 week ago. Well, but it is somehow unusual that today we'll have quite some bonus point. Okay, although we only have 1 hour lecture, so get prepared to answer questions. Some of them are easy. Well, at that time, when that happens, you have half bonus, and then some of them are really challenging. So some of them may have 1 or 2 even bonus points. So I guess we'll start, okay? Let me share the slide. Okay, so in the last lecture, we talked about the fair division of divisible goods, right? So about cake. And you can have some interesting protocols that can get you some proportional or envy-free allocations. And then in the end of the last lecture, we talk about the mixed goods case, right? Okay, remember that in that IIII paper, which won the Best Student Paper Award, they define the envy-free for mixed goods in the following way. They say, okay, if one agent, so this agent J, its bundle only consists of indivisible goods, okay, only indivisible goods, then we just apply the traditional EF1 concept, okay? So in other words, so your target, right? So this is yourself, VI is yourself, and then this J is your, well, this is yourself, and that's another party's bundle, right? So if that another party's bundle only consists of indivisible goods, then the envy-free concept is defined as EF1, envy-free up to 1, which means I can remove one item from that target and to see whether you still envy him or not, right? Well, if no longer, then we say, oh, it's okay, right? And then when the target, so if the target consists of not only indivisible goods, but also some kind of divisible goods, then you need to follow strict envy-free concept, which means, well, as long as you get some money, right? So your opponent gets some money, then you say, okay, I would require that I value your bundle as much as mine, okay? So at most, as much as mine, cannot be higher, okay? If I think your bundle is higher, that's not good, okay? So they define the envy-free in the following way, in this way, right? And then you see that this EFM, the envy-free for mixed goods definition, it will reduce to envy-free for divisible goods and also reduce to EF1 for indivisible goods. And actually in their paper, they prove some interesting results. And actually last time, some of you asked me about some details. So today I'm going to talk about them. Now the main thing is, the main result in their paper assume that there is a perfect cake cutting protocol. All right. Okay. So the general idea, they start with an EF1 allocation of indivisible goods. Now this one is easy, right? So you can just use round robin to let agent pick items. So in the last lecture, we already know if we follow that process, nobody will envy other people by more than one item. Okay, and then with this EF1 allocation, they will further add the cake. But they add the cake in a certain way that this EF envy-free property is still maintained. Okay, so they will add cake very carefully, incrementally. Now, whenever you add some cake, it always guarantees that, well, the whole allocation is still good. Okay, so basically they will maintain this so-called EFM property throughout the whole process. Okay. Now, in order to illustrate their protocol, we'll first talk about the so-called envy graph, and this one will also be useful in our today's discussion. Okay. So what is envy graph? Oh, very easy. It's just describing whether some agent envy some other agents. Okay, so you have an edge from I to J if you think your own bundle is less than some other people's bundle. Okay, so basically I envies J, then there is an edge from I to J. That's really very easy, right? Okay, now there are also some kind of so-called equality edge with this dashed line. So basically it thinks, okay, my bundle is as valuable as your bundle. And then I draw an equality edge. Now here, one example, right? Now suppose the blue person gets the house, the orange person gets the car, and then the green person gets the diamond. And then you see that they are now having these items. And then we can see the orange person will envy the green person. Why? The orange person gets the car, but diamond is very valuable to him too, right? Even more valuable. So since the green person gets the diamond, then of course the orange person thinks the green person gets more. So or the green person's bundle is better, right? Because green person's bundle has a value 4, but his own value is only 3. Therefore, we have an edge, right? From the orange person to the green person. Okay, and then for blue and orange, these two persons, they are the same. They have equal edge, equality edge. Why? Because they think house and car are the same. Therefore, it's okay, right? So for the blue person, he is allocated a house, but he thinks car is equivalent, right? So he has an edge towards the orange one, but the dash edge is equality edge, right? And vice versa. This direction is also true. Okay, so now we will talk about the so-called addable set. Okay, so addable set means what? Addable set means we can add some cake to the set. Okay, now the property that need to be maintained is the following. Firstly, there is no envy within S. So basically, within the set, nobody envy other person. Okay, and the second, there is no edge from people outside to this set. So in other words, people outside do not envy people inside S. So if I give people inside S some minor increase or some small amount of money, it should be fine, right? So other people still do not envy people inside this group S. Okay, so now you can imagine the process is basically trying to locate some addable set, right? So locate such a set such that nobody else will envy anyone inside. At the same time, people inside the set also do not envy each other. And then we try to add cake on top of it. Okay, so for this set, right? So for this set, you see that this set, the edges between people inside, they're just dash edge, right? And then for people outside, they do not envy, right? So you see that there is an orange edge from the orange person to the green person, but no edge from the green person to anyone inside the set. So basically, the green person does not envy anyone inside the zone, right? So, well, with this property, you see, if we add a small piece of cake to each of the person inside the set, it should be fine, right? But we need to make sure that the piece of cake we add to each person in the set should be the same to them. Okay, so in other words, we are adding the cake to these people inside the red or the yellow zone in a somewhat equal way. So everybody get a piece which he or she thinks is equally valuable. All right, so that will not introduce extra envy inside the range. At the same time, because nobody else outside envy the people inside, so basically adding some small piece of cake also will not cause some further envy, right? As long as the amount we added is very small. Okay, so this is the general idea. And then here, they assume they can call the so-called perfect allocation of cake cutting. Okay, so this is the protocol or black box they called. They say, okay, now I would like a perfect allocation such that everyone in the set gets the same value of the cake they think. Okay, so that's the general idea. Now remember, you can ask me questions anytime during when I'm explaining the concept. Okay, so now the question is, well, can we always find an addable set? Can we? No, right? Okay, very good. So you cannot always find addable set. The reason is, well, sometimes there are cycles, right? Okay. Now, yeah, so remember, I will give bonus to the first person, all right? So try to be quick for those who didn't get it this time. Okay, now, you see, when you look at this picture, you see that actually this picture, there seems to be a problem to find a set, because for example, if you find the set to still be this one, this seems not good, because although this green person does not envy anyone inside, well, but this is the equal edge, right? Equality edge, which means as long as you add a very tiny piece of cake to this blue person, then the green one will envy, well, will envy immediately, right? So that's not good. But that also says that, well, when you cannot find addable set, then definitely you can find an envy cycle. Okay, now of course I'm not going to prove this, but it should be not difficult. All right, so here you see, well, what is envy cycle? Envy cycle is that, it's a cycle with at least one envy edge. So here you see, there's a cycle, orange, green, and blue, right? So at least one of the edge is solid edge, which is a true envy. The other one can be, well, equality, but well, at least one of them is true envy. So this kind of cycle, when it exists, then what can you do? You say, okay, after I find the cycle, I can simply do the so-called envy cycle elimination. What to do? Well, I guess all of you have already have the idea, right? So basically, just swap the bundles, right? For example, I orange envy green. Then I say, okay, I give green's bundle to orange, right? I give this bundle to him, right? And then, well, orange will no longer envy, right? And then similarly, this direction, right? I give the blue person's bundle, which is house, to the green person. Then this edge is also gone somehow, right? Okay. And then, well, the other edge is also following the same reasoning. So with this envy cycle, you do a shifting of the allocation, then, well, at least no envy along the whole cycle anymore, right? No true envy exists anymore, okay? Well, so the key lemma here, there in the paper, is that in any envy graph, there exists either an addable set or an envy cycle. Oh, that's good. So we know that addable set, we can just add a small piece of cake to the people inside and then still maintain the good property. While for envy cycle, it's easy to shift the allocation and reduce the envy. So eventually, all the envy will be gone, right? So you see that we are always making progress in the whole process, and we will repeat until all the indivisible resources are allocated, right? Okay, and then in the whole process, we always guarantee, well, it's somehow EFM. Okay, well, so I'm not going to talk about the details, but I guess you already have the rough high-level idea of how they achieve this. Okay, now, but as I said, right, so they use the so-called perfect allocation oracle. But we know, well, actually computing such a perfect allocation where each person considers his own piece of cake to be the same as other people's value, then well, this one itself is not so easy. All right. So basically, to be more specific, in the Robertson-Webb model, then this perfect allocation cannot be implemented in bounded time, which is not good. Therefore, there's still an open question whether a bounded EFM protocol can be found in the RW model, right? Okay. Now, well, in order to get rid of that perfect allocation oracle, then they design some kind of so-called epsilon envy-free for mixed goods. So this epsilon is relaxation. It has some sense or some similar flavor as approximation. So basically, when you see this definition, you see, when I consider whether people envy each other or not, I have a very small tolerance epsilon, okay? So as long as the value of my bundle is not too far below another bundle, then I'm still okay. For example, I think my value, my bundle's value is 9, and I think the other bundle's value is 10. Okay, so if this epsilon is 1, then still fine, right? So because, well, the other one is 10. After subtracting 1, it becomes 9. So my bundle is as good as 9. That's good, right? Okay, so with this relaxation, they can get some polynomial time protocol to derive the allocation. Okay, so this is another result. Now, this one is actually not a trivial algorithm because even we consider the epsilon perfect allocation of cake, it still needs a time exponential in 1 over epsilon, but their running time is polynomial in 1 over epsilon. So basically, they cannot simply call the epsilon perfect allocation, right? Okay, so I guess this is all for the goods case. All right. Now the summary, I guess I don't need to mention anymore. Well, if you are interested, you may look at some recent papers, especially well, there are some kind of fair division survey paper, well, which is about to appear very soon, and one of them is already on arXiv. Okay, so that one we will just go to the end, right? Okay, so now in the remaining time, in the first hour, we'll talk about, or we start the topic of dividing tasks. Okay, so we finished explaining goods, and then we talk about tasks. Now, in these tasks, we also call them chores. All right. Now, the formal definition has the following well, setting. You see, we have a set of indivisible chores, or we call BADs. All right, and these are labeled 1 to m, and we have a group of agents 1 to n. And there is a cost function. Now, remember, in the goods case, it's a value function, right? But now it becomes cost. So everyone wants to have a small cost of the items allocated to him or her, right? Okay, so the cost function is CI, right? It's also additive, usually assumed to be additive. Okay, and then now we assume that the cost will always be non-negative. All right. Okay, and then again, an allocation is very easy. You just divide all the items into n bundles and give each bundle to the corresponding agent, right? And then, well, it seems to very, very similar with goods, right? In goods case, it's also like a partition into bundles and then give each bundle to a corresponding agent. Okay, so now, well, let's see how to define the objectives. Well, actually, objective is also quite easy. Well, just a very minor twist. But what kind of minor twist? For example, we can consider to minimize the overall cost of all agents, right? Summation of all the cost. So this one is called the utilitarian. And then the other one is we try to minimize the maximum cost. Okay, minimize. So in the goods case, it's not minimize, it's maximize, right? And then the other side the same for the goods case. Now, other than changing C to U, right? Is this sum and max the same for goods? Okay, yeah. You can be certain, right? It's no, right? Yeah, so Anu said it should be mean, right? So for the goods case, this one should be mean, it's not max. Okay? Okay. Let me... Okay, now, so in the chores case, these two objectives, they are very well, also very well known. And then you may ask, why not? So it seems that the egalitarian one is more fair, right? This objective is fairer. We want the maximum cost to be as small as possible, right? Oh, wait for a moment. Why my mic will be unstable? It's very strange. Because I'm using a headset. Is it still not stable? Is it good? Just want to make sure things are okay. Okay. Wow. Okay. Now it's good. Well, so please let me know when it's not good. Yeah. So because well, I cannot think of further ways to keep it stable after using a headset. It seems that I should also kind of exchange my headset to a new one. Okay. Okay, and then Ziao asks, it seems that social cost is less than or equal to n times max cost. Yes, you're right, right? But these two objectives are still different in terms of optimization. or even approximation, because you minimize the max. It does not mean you can minimize the sum, right? Because n times max is only an upper bound. Okay, and then also, well, now especially when we say that we do not focus on this one, is that people have different understanding about, or different feeling about the so-called egalitarian objective. And then Xiao further asks, if we optimize max cost, then we find an n optimal. Yes, you're right. If we optimize the max cost, then we find an n approximation of the well, minimizing the social cost one. This one I believe is correct. Well, but anyway, correct me if I'm wrong. Okay. Yeah. So now here there's also one interesting observation about goods and chores. All right. So one thing is the following. Now suppose, all right. So now I'm asking you another question. So for the goods, it's a kind of UI, right? And for the chores, now suppose we define the cost to be 1 minus UI. Okay, we define the cost, CI, to be 1 minus UI. Okay, and then it seems to me that minimizing the cost is equivalent to maximizing the U, right? Is that right? If I change if I define CI to be 1 minus UI, and then minimizing the summation of C is the same as maximizing the summation of U. This is right, right? Okay, so then does it mean that, well, actually the chores problem is meaningless, because for goods we already have a solution, suppose, right? And then it's very naturally translated to the solution for the chores. Am I right? Okay, yeah, okay, no. So tell me the reason. I see a lot of no's. Oh, that's good. But then tell me the reason. The reason will get bonus, okay? So this time, a single binary answer will not get a bonus. Okay, you need to give me the reason. Sorry, I'm scrolling up a bit. Yeah. So what's the reason that they are not the same? Range? Because it is already there. Not quite. Okay. Goods we use product. Oh, in goods we didn't use product. Product is for national welfare. Cost should be non-negative. Yeah. Yeah. Okay. Let me clarify myself a bit. Okay. So suppose all the U's are less than 1. Okay. So cost is non-negative. So the question is, you see that when all the U's, they are between 0 and 1, and then if I define the cost to be 1 minus U, this is also between 0 and 1. And then minimizing the cost sum is equivalent to maximizing the summation of U. So does it mean that, well, since we already discussed a lot about goods case, then chore, we don't need to discuss at all, because solutions for goods automatically become solutions for chores. Now this one, this bonus carries a quite heavy weight. The reason is, well, it needs your knowledge about earlier topics. So up to now I didn't. So one minus U is also, we can add it, right? The utility is not equally weighted. Well, we can assume the utility is equally weighted. Okay, so, well, anyway, we can know that optimization, the concept of envy is not the, okay, so Ziyao answers half correct about the solution. I guess this one, Ziyao will get 0.5. So basically, one thing is, envy is not defined in a similar way, okay? Probably, we'll go to it very soon. But there is another very, how to say, so if we only talk about the utilitarian objective, we do not talk about envy yet, okay? So if we do not talk about envy, we just focus on this objective, then are they the same? Because we said that minimizing C is equivalent to maximizing U. Okay? They are equivalent. So since they are equivalent, then doesn't mean that if I solve one problem, then automatically I solve the other problem, right? Because they are equivalent. Okay. Okay. Now this one is really challenging. Now maybe I will move ahead due to the time. Okay. Now remember, I said that this answer needs your knowledge about earlier topics. So what earlier topics? Well, the earlier topics is about APP. Okay, of course it's not app, right? What is that? Oh, very good. Okay, so Zhengwei, after the hint, you get the bonus. Okay. So basically, now of course this one is only half now. Okay, now approximation. All right, approximation algorithm. Even though optimization is the same, so you maximize UI is the same as minimizing CI, summation of CI, but usually, if in order to achieve some fair concept, you cannot use the optimal solution. You can only use approximate solution, right? When you only use approximate solution, then maximizing UI's approximation will be different from minimizing CI's approximation. Okay? So this one, at the topic of approximation, we didn't mention much, but here we can say something. Okay? Now suppose the summation of UI, all right, the best solution is 8. Okay, this summation of UI. Okay, this is UI. And for CI, the best summation is 2. Okay, so the minimum summation is 2. Okay, now which means, well, total is 10. And then suppose for UI, I can do half approximation or 2 approximation, which means I can achieve 4. Maybe this is not good example. Let me use another one. So suppose we can achieve some ratio like 4. Okay, which means that I can get a utility sum of 2. Because the total is 8, so I can get 2. I can achieve 4 approximation or 1/4 approximation. And then when you translate that into again, it's not a good example. When you translate it into cost, it becomes 8. Well, but again, it's a 4 approximation. This is still not a good example. Let me change it to another one. Say 7. Okay. Maybe 7 is better. All right, I changed it to 7. So this one is a very close to 1 approximation. It's a 7/8, right? Or 8/7. But then your cost becomes 3, right? So corresponding cost is 3. Now when you divide 3 by 2, it's a 1.5 approximation. So in terms of approximation ratio, for the cost problem, it's worse than for the utility one, right? Okay, because for the utility one is 1.25, but for the cost is 1.5. Therefore, when you talk about approximation, even though 2 objectives, they complement each other, the approximation you can get for each of them will be different. Okay, so this is another message I would like to bring up to you about approximation algorithms. All right? Okay, so I hope I made myself clear. And then we move on. Now for just a brief summary, all right? So for fair allocation, there are 2 main directions for study. One is people try to develop the so-called conceptual work to measure fairness. So basically, people will define different measures of fairness so that, we can get reasonable results, analytical results out of it, right? So this is about conceptual work. The other one is algorithmic work, which means, with these fair measures, we want to compute fair allocations, how easy it is to compute fair allocations. And we can see that this research is at the intersection among the computer science, mathematics, and also social science or economics. So there's a very interdisciplinary research. Okay. Now, about fairness, remember we defined 2 earlier, about proportional and envy-free, right? Okay, so let's see, in the chores case, what is envy-free and proportional? Sorry, again, it's unstable for some time. Let me change to another socket to see what it's better. Okay, so I changed to another socket, and I hope that it will be better. Let me know if there is some unstable thing. Now, for chores, envy-free is defined very similarly. Well, because it's cost now, we hope our own cost is not as big as the other cost, right? So we hope that other bundles cost is at least my bundle's cost. So the only difference compared to the goods case is that the equality sign becomes less than or equal to, right? Becomes less than or equal to. So this is envy-free. And proportional, also the same. And the only difference is what? Again, goods case is larger than or equal to, but chores case is less than or equal to. We hope that we get only 1 over n total cost of the whole bundle, right? Okay, so these two will be exactly the same. And then again, as usual, in the goods case, we can know that any EF allocation is also proportional, right? Because you get less than other bundles, of course, you get less than 1 over n of the whole bundle, of the whole set of items, right? And then another thing is, let me check my setting a bit. Let me check my setting. So sound. So I unticked the adjusting microphone automatically. Is it better now? Okay, good, good. Now I hope that the unticking will be good, because I remember that I tick it. If I do not use a headset, it's okay. All right, so let me just, okay. Yeah, let me know if it's not good. Now, another thing, we know that the envy-free allocation or proportional allocation may not exist. So it's the same as goods, all right? Again, may not exist. And then, well, we know that it's still very similar as goods, and except the so-called alpha proportional. So alpha proportional, that it means that you can, well, your cost is at most alpha times n over 1 over n CIM. In the goods case, this alpha probably should be at the bottom. Okay, it's here in the goods case. But anyway, it's still not a major difference. So the major difference comes when you talk about EF1. So how about if I move this up? Well, so is it okay? Okay, yeah. So envy-free up to 1. The definition here, when you look at the definition, what do you have in mind? What's the difference between this envy-free definition and the envy-free up to 1 for goods? Now, this will be half bonus. So, did you hear my question? Oh, okay. So what's the difference between this EF1 and the goods EF1? Minus become division. Target, XJ. Okay, I also see some earlier answers like remove ones. I try to, okay, so Le Chen, you got the bonus, okay? Okay, so the point is, in EF1 definition for chores, you see that we are removing his own item. Okay? So in the goods case, we are removing an item from your opponent's bundle. But this time, you are removing an item from your own collection. Well, this is a bit strange, right? Okay, so you may think, can I, because it's chores, right? So if I remove an item from my opponent's bundle, it's always good, right? Oh, it's always bad because earlier I envy him, now I envy him more because he has even less. That's not good, right? Okay, so very naturally, you cannot remove some item from opponent's bundle. Now there are two options. One option is you remove one item from your own bundle so that you get assigned less and then you will no longer envy others. That's one possibility. And there is another possibility that you add one item on your opponent's bundle, right? But which one do you add? It seems very uncontrollable, right? So therefore, well, because adding item here seems very, very unstable, just like my voice, okay? So you don't know which one to add. And then people define the envy-free up to 1 in the following way. So they remove one item from your own bundle. If removing that make you no longer envy others, then it's good. Then it's EF1. All right? Okay, and then similarly, we have another definition for EFX. So if you remove any item, you will no longer envy others, then it's okay. All right? Okay, now again, as usual, as in earlier discussion, EF1 means remove remove some, right? You can remove the largest one. Remove largest one, then of course you will have a less chance envying others. And for EFX, remove any, right? So it means remove smallest, right? You have to guarantee removing smallest will also allow you not to envy others. Then that's good, right? Okay. And then a very natural observation is that EFX definitely is EF1, right? Remove any will guarantee the property. Of course, remove some will also guarantee the property, right? Okay, and then in the chores case, we have some known results. So one is EF1 always exists, all right? But again, for EFX, it's very challenging. Remember, in the goods case, EFX is also challenging, right? And for the chores case, EFX is also challenging, right? Existence, whether it's exist or whether you can do some approximation, both directions are challenging, are open questions. Okay, so now let's look at one EF1 algorithm, which is very similar as before. It's again round robin, okay? So how to do it? Well, you have two agents here, and then the first one pick one object, and second one pick one, and then first one pick one again, and then second one pick one again. Okay, you keep doing it. All right, you keep doing it. All right, so in the end, you have this allocation. Now, just like before, this is EF1. Why? Because, well, the first, so because everyone picks the smallest item in the current set of remaining items. So if you remove this one, then this guy will not envy the others because this cost is better than the other one, right? So this is better than this, right? This is better than this is better than this is better than this. So basically, the second agent will be very happy if the first agent does not have the first one, right? And then, well, the first agent will also be happy because in his view, this cost is less than this cost, right? This cost is less than this cost. This is less than. This is less than. So if I do not have the last item, then again, I will be happy, right? The first agent will still also be happy. So basically, this is a very natural envy-free up to 1 algorithm, right? Okay. But, well, one thing is, this algorithm only works for the so-called additive valuation. If you can add all the values together of the items, then it's okay. Now, there is a smarter greedy algorithm, which is called envy cycle elimination. And this one, we mentioned it before in the mixed goods case, right? Envy cycle elimination. But here, in order to handle chores, we need some tricks. Okay, so let me first explain the background of the algorithm. Now, the background of the algorithm is we try to select the biggest beneficiary and then ask him or her to get an item. Okay, so biggest beneficiary means what? It means that somebody who does not envy others. So for example, if A1 does not envy others, which means cost of A1, right? Cost function of A1 for bundle A1. Cost function of agent 1, right, for bundle A1 is less than or equal to C1AI, which means, well, for other bundles, the cost will be higher in the view of the agent 1, right, compared to its current bundle. So the current bundle is A1, so agent 1 thinks A1 is the best. A2, A3, A4, A5, they are not good, okay? A1 is best, okay? A1 is best. Well, so that means A1 does not envy any person. And then you see, in this case, if I give A1 another item, it should be good. At least A1 will not envy other people up to one item, right? Because I can simply remove the newly assigned item, and then I'm very happy because my cost is smallest, right, among all the bundles. So if there exists such a person, then giving him an item would be good. It still maintain the EF1, right? Because as I said, right, if you remove this extra item, then it's smaller than the cost of all the other bundles, right? Okay. Well, so but the question is there always such a person? Can you always find someone who does not envy anyone else? Yes or no? Okay, so again, it's a speed contest. Okay, so it's no. The answer is no. Why? Because well, sometimes there could be cycle, right? So in other words, it's possible that in A's perspective, B's bundle is better, and in B's perspective, A's bundle is better. Okay, well, but that does not cause a serious issue because, as we discussed earlier, you can simply shift the allocation to remove the envy, right? Okay, so let's see whether we can do it very smoothly. Here's one example. So suppose we allocate item in the following way. Okay, and then you have an envy graph. All right, and this envy graph looks like this. There are 4 edges. All right, let me analyze one edge. Okay, the other ones is very similar. So let's analyze one edge, A3, A1. Okay, so you see there is an envy edge here, right? Why A3 envies A1? Okay, remember A3 is allocated this one and this one. Okay, A1 is allocated this one and this one. Okay, so the cost of agent 3 is 11, right? But agent 1's bundle, agent 3 thinks its cost is only 2, right? Because you see, the cost here is 2, 1 plus 1. So agent 3 will envy agent 1 because he thinks agent 1 got, so in the viewpoint of agent 3, agent 1's bundle, its cost is only 2. But now agent 3 gets a cost of 11, right? That's not good. So there's an edge from A3 to A1. Okay? And similarly, you can, well, derive, right, the other 3 envy edges. Okay, so you see that actually this work is very recent, 2021, right? Okay. Now, what do we do? Okay, now we try to locate envy-free agent. Okay, so in other words, we want to find someone who does not envy other person. Okay, well, and then if there's no such person, so if there is a such person, then we probably can give him or her an item. Then that would be good, right? But if there's no such person, that means there is a cycle, right? So just like here, we have cycles, right? A3 to A2 and A2 to A3. This is a cycle. And another cycle is A3, A1, A1, A3. It's also a cycle. So now the trick is, well, you can redistribute the bundles along the cycle, right? Now let's see what happens after we redistribute the bundles. Now suppose we are looking at this one, this cycle, okay? And then we swap the items. C2, C5, I give it to A3. C3, C6, I give it to A2. Okay? Now after I redistribute, then what's the envy? Okay, so the envy basically, A3 is still, well, so the envy is something not very, so it's not very well expected. Why? The reason is what? Well, let's see. You see, after you swap, right? After you swap, then you see A1, originally envy is A3. Because A3's bundle goes to A2, so now A1 envy is A2, right? Okay, well this one is okay, right? This one is okay. Now of course the cycle here disappears, right? They do not envy each other anymore. And then what's the other one? A3 envy A1, okay? So A3 envy A1 is still, well, it's still here. A3 envies A1. Well, so this one, actually, for the goods case, it's already done. So basically for the goods case, you swap bundles along the cycle. Then after swapping, the whole picture will be pretty good, okay? There could be no longer cycles, and then, you will go forward very smoothly. But for the chores case, it's a bit different. So actually, you can already see that there's some strange thing here. Usually when you swap bundles, the arrows will just follow your swapping. For example, if I swap bundles, in the goods case, then what will happen? So in the goods case, actually this edge is not here. The edge is not here. It's not here. It's what? It's here. All right? So for the goods case, it's somewhere here. But for the chores case, well, it's somehow not normal. And actually, this solution is very bad. Let's see how bad it is. Okay, so Jiangpeng asked whether we are focusing on egalitarian. So actually, we are not focusing on any objective. We are only focusing on envy fairness. Okay, we are only focusing on envy free. All right. Okay. Yeah. So for this solution, let's see whether this solution is good. Now, we hope that after swapping, earlier it's envy free, and now it is earlier it's envy free, and now it's envy free up to 1. So we will always maintain it's envy free up to 1. But this kind of swapping on chores, it cannot maintain that. Let's see the calculation here for A3. All right. So for A3, the new cost is 3 plus 3. All right, let's see these two. Okay, but A1's bundle is 1, 4, right? So the cost in the point of view of the A3 is 2. So you see that even if I remove an item from 3, he still thinks it's not good, right? Because even if I remove one item from 3, 3 still thinks his cost is 3, which is larger than 2. And 2 is cost of the other bundle. So A3 is very, very unhappy. He thinks that, well, after swapping, I didn't even maintain EF1, right? That's very bad. That's very bad. So now comes the bonus question with a very high weight. What do you think causes this problem? For the goods case, there is no such problem, right? So for the goods case, if you swap along the cycles, well, the cycle is gone. The other thing also, well, move very naturally. So basically, after swapping, you can find one person who envies nobody, right? Yeah. So we are trying to find the one who envy no other person, but we want to maintain the envy-free up to 1 property for all the people, because if we cannot maintain that, then there's a trouble, right? You're right. So Jianghui, you're very right. You're very correct. We are trying to find someone who does not envy other person. But for those who envy, you cannot allow them to envy more than up 1 item. Okay? Well, so now, what's the major reason that, well, after this swapping, yeah, different view. But actually, for goods case, it's also different view, right? So there's one core reason which make this happen. And this core reason has something to do with what we explained earlier about the envy free up to 1 concept. So this is some hint I give you. Okay, so for the goods case, EF1 means what? EF1 means you are very good, okay? Yeah, so, yeah. Xinju, you got the bonus. Okay. So basically, the reason is EF1 definition for chores. You are removing from your own bundle. Okay. But for goods case, you are removing from other people's bundle. So if you remove from other people's bundle, after you swap the bundle, for example, for A1, right? So we want to check whether I still envy A1 up to one item, right? If I swap with other bundle, for example, A3 swap with A2, right? After swapping, my own value increases. And then my opponent, A1's value, it doesn't change, right? And then I'm removing something from A1's value. Well, okay, then that means my benefit strictly increases. Other people's benefit didn't change. So that's good, right? That's good. So after swapping, originally there's no such edge. Now there's also no such edge. But now it's a different story. For chores, you see, after I swap bundle with my partner, although my overall value increases, right? But remember, this EF1 is defined as what? Removing one item from your own bundle. So even if my overall increases, it does not mean that after removing one, I also increase. Get the point? So basically, you are now changing your own value, not changing your value perspective towards your opponent, right? Okay, so after you get a new bundle, although the new bundle, the sum is good, the total is good, oh, okay, the total value increases. But if I ask you to remove an item, then it may not be good, because you can imagine some examples. Suppose I have a 3-3. After swapping, I get 3-3. And earlier, I'm 6-2. Okay? So earlier, I'm 6-2. After I swap, I get 3-3. So 3-3 is smaller than 6-2, right? Because 6 is less than 8. So it's better, right? This one is better. But after I remove one item, I still have 3. But for this bundle, if I remove one item, I only have 2. So after swapping, I become worse. So originally, I may not envy that person, but now I envy it, right? Okay? So that's the tricky part for chores case. Okay, now I will skip the remaining details. So basically, because of this, then people need to think about how to do it, right? How to eliminate the cycles. And then we need to define the so-called envy most. Okay, although A3 envy A1, both A1 and A2, but A3 envy A1 most. Okay, therefore the black edge has a reason to be black, because this edge will not exist in the another algorithm. Okay, so the black edge exists if we only consider envy, but if you consider envy most, then the black edge is gone. There is no such cycle. Okay, because A2 is not the critical person. A1 is the person that A3 envy most. So we only create those red edges, and then there is only one cycle, one envy cycle. If you eliminate along that cycle, then you can guarantee the property. Okay, so that's the reason, right? So that means if you swap A3 with A2, then that envy still exists. That's not good. That's not good. Therefore, we would like to swap A3 with A1 instead. Okay, so we will not have this edge. Then you resolve the top cycle. Okay, the most envy direction. And then if you use this so-called top envy cycle elimination, then the resulting allocation will always be envy-free up to 1. Okay, well, so this is the theorem in their paper. And then I guess today I will just stop here. And then there are some open questions, but yeah, so this one I will not go on further today. Okay, so now it's about the preparation time for the midterm quiz. Now, of course, you are still welcome to ask questions. Prepare your second device, make the angle right, and then also open your camera of your first device, and make sure that recording will start at about 12:58 or 12:59. Okay, the exam or the midterm quiz will start very soon. Okay. Oh, okay. So I will explain the utilitarian objective and egalitarian objective. So basically, utilitarian just means sum. I add all the cost together, or I add all the utility together. This is utilitarian objective, right? And egalitarian. So these are words from the social choice domain. And then egalitarian just means this is the cost or utility of the extreme person, right? In the cost case, it's the one who has the largest cost, right? So egalitarian objective is the largest cost among all the agents. Well, so also it's a very natural to feel very challenging to follow today's one, because you can imagine that today we are talking about what? This one. This algorithm is actually developed just in the last year. So it's very up to date. And that also means that, well, actually, it takes some time to understand the reason behind using the so-called top cycle elimination instead of only NV cycle elimination. Minimize the maximum cost. Yeah, so egalitarian objective is just the maximum cost in the choice case. Okay, so one question about midterm quiz. Midterm quiz, the total exam time will be 1 hour and 50 minutes. After that, you can use your first device to monitor your photo taking and uploading process. Okay? You do not need to record the first device in the Zoom. That's not necessary. You only need to record your second device video. Yeah. If you can use a third device to take photos, that would be perfect. If you are recording second device, if you are recording on your second device, then you don't need to do Zoom recording. You're right. Okay, just make sure you have a recording of your second device. Either you open a private meeting and using Zoom recording to record your second device, or you simply use your second device to record the picture or the video you capture for your exam environment. The process of transferring the answer into PDF, if you don't have a third device, you don't need to record that, but make sure that you capture the whole process using your first device when you are taking photo. So after you're taking photo and upload the file, if you use your desktop computer to transform them into PDF, then your second device should somehow still capturing that. But I would trust you in this because it's anyway a last moment upload, so it's okay to waive that part too. Yeah, so if you finish early, you can message me and start scanning. That's totally possible. Yeah, that's totally feasible. And also some forecast about the lecture next week. So actually the one starting from the beginning of next week's lecture will be very, 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 how to say, I don't know how to use the word. So basically that algorithm is very beautiful. So I can say that this most beautiful one I've seen in fair division. So yeah, make sure I will go through the one together with you, and I believe you will feel the beauty of that algorithm too. And then because the transferring into PDF may be done on PC. Okay. Yeah. Transferring done on PC. So I would trust you on that. Anyway, it's only several minutes. You are uploading changing the pictures to PDF, so it should be fine. Yeah, by the way, it's paper and a pen, pure written, okay? You cannot type, all right? Write on paper, and also it would be good if you write your answer for one question on one paper, on one page. That will be perfect, okay? And then we take photos. Each photo will be the answer to one question. Well, as I said earlier, you can use tablet to write, but you need to capture that in your second device recording. Yeah, you're right. You're right. Okay, so I guess you can access the quiz now. Oh, and meanwhile, what I said is next week, the beginning, the lecture, the algorithm will be very elegant. So I hope you will not miss it. Okay. Well, screen recording of the tablet. This one I don't. It would be good if you use a second device to capture both yourself and the screen. How to eliminate background means what? Can you download the file? Okay, good. Good. Yeah. We can start. Oh, sorry. So the assignment, the midterm is in the quiz category. And then when you click in, you can see midterm quiz. And inside midterm quiz, there's a question 1. And inside question 1, there's a PDF file. So there are 15 minutes more. Take your time. You will have time to take photos after the exam finishes. Okay, no worry. No hurry. Okay. So now the quiz time is over. Yeah, please take photos, transform them into PDF, and upload. So take, well, just make sure that your photo is clear enough for marking purpose. And then while you are taking photos, for those who finished taking photos, you may answer some simple questions. The first query I would like to ask you is whether you think that you get a grade higher than 50. Okay, so if it's yes, if you think it's higher than 50, click yes. Otherwise, click no. Okay, so I just want to get a rough feeling. Yeah, take a photo first. The survey is not in a hurry. Okay, so uh, there are some common questions. For example, the video is very big, right? So usually there will be a possibility of compression, and then after that you can upload. Now, even if you do not compress, say for some videos like 10 gigabytes or something, it's still okay, I think. And yeah, you can upload the video within this week, anytime. And then the upload is to OneDrive. This is stated in the midterm invigilation announcement. Okay, so upload to OneDrive and share the link to my TA. Okay, how to convert to PDF? This is a tough question. I guess there are some tools. And then yeah, so you can upload your paper now. Submit as images may be fine. You can, but then it will, well, increase some uncertainty. But if you can, I would advise you to convert it into a PDF. So there are many solutions posted in the chat. Yeah, it's only one file. Yeah, I guess there's only one file upload possible. Yeah, you can. Yeah, you're right. You can paste. So Jianchuan is right. You can paste the images into Word and then transform Word into PDF. That's also okay. Yeah. So these are all possible approaches. And then there are also some other questions about how can you check whether your uploaded file is okay after submission. I guess you can see your let me see. Let me switch to student view to see what. Let me see. Yeah, maybe due to my setting of the quiz. Usually after uploading the file, it should be okay. Yeah, so I see many of you posting your quiz has been muted, which means you cannot try any further, right? So it's a trying once, so it should be fine. If you want me to, well, check whether the file is okay, I could help you to check. Yeah, so let me check. Yeah, so basically it should be okay, unless you upload the wrong file. But for the two of you who asked me to check, let's see what I'm missing. Oh, so Dim Sum, you upload the wrong file, I think. No, not you. Not Tim Sum. Let me just check the. Yeah, so in case you think you are worried about the wrong submission, you send an email to me and CCTA. That will be safer, okay? In case you upload the wrong thing, right, that could still safeguard. So yeah, Xuejun is fine. Okay. Yeah. Okay, so so generally you should believe that you chose the right file, but if you are uncertain, send us an email. Okay, right now. Yeah, Jiankun, yours also fine. Now I would like to Zheng Wei, let me. So Zheng Wei, actually you didn't upload anything. I didn't see that. So it told me unanswered, question 1. And so you didn't need to be hurry. There are only 2 or 3 minutes for uploading. Yeah, Yuanhang, yours is fine. So Zheng Wei, the problem is the comments. Oh, I see. I see that. Fine. I found it. Okay, then it's fine. Yeah, I see that. Yeah, usually your quiz has been muted means you should have successfully submitted. Yeah. So one Qian, well, so yeah, in case you find that it's a problem, send email immediately to me and my TA. Okay. Yeah. So well, just a brief summary about the midterm quiz. Now, I said that my target is 60 points, but actually this target cannot be achieved, definitely. Okay. So you do not need to worry too much if your answer is below 50. Okay. And actually, I'm going to ask the second question. So the first question I'm asking you, do you think your mark is above 50, right? And then I see about 30%, maybe less than 30, 20 something percent, answering the question by yes. And then I'm going to ask the next question. Do you think your mark is above 30? If yes, press, so if you think it's above 30, click yes. Okay, yeah. So this time it's reversed. Okay, so basically it's well, something like 70 to 80% thinks above 30, and some of you think less than 30. Now you can see that actually based on these two queries, you could imagine the average mark of the quiz will most likely be 40. Okay, well, but that's not bad news because you know assignment usually many of you can get very high marks. Okay, so to balance, your course will not be too bad. So relax. Okay, no worry. And then, but then one thing I would like to remind you, that thing is about the questions. Okay, so you see that midterm question. I didn't give any questions that's very simple, which means some definition. Okay, so what is Nash equilibria, or what is something like that? So I bet these questions are meaningless, right? It's only a test your memorization. Well, that's not good. Now today's question actually. Now I would see some answers, some feedback from you. For game theory part, actually I believe you will feel quite happy about question 4 because it's just a very similar one as the assignment, right? Okay. Yeah, I also see that some of you say you need more time. That's for sure. That's for sure. I'm intending to make it, well, time hungry. Okay. So that's my purpose, right? Otherwise, well, it will not be good, right? So now I guess there are some questions about final exam too, right? So final exam. Well, I know that there is a 30% passing criteria, so you could imagine that final exam will not be as difficult as midterm. So this is something for sure, all right? I'm not going to fail many students, right? So at least I might, it's not my intention. And then I also do not think you will fail the course if you study well. That's not fair. And then but I will not give memorization question, okay? That's not my style, all right? I still will give computation type or analysis type question or design type question. Yeah, but the scope will be narrower. I'm not going to require you to review all the topics covered up to now or up to the end of the semester. That will be too much burden, all right? So I will narrow down to several topics only, okay, for the final exam. And yeah, so Chaojie asked, will not contain algorithm. That's not, that's something I'm thinking, but I can only say I will not cover pure algorithms, all right? So the algorithm can be in the game theoretic environment, okay? It can still be certain things like that. So I cannot say I will not cover algorithm. That's not possible, okay? Well, but yeah, again, well, mechanism design is one possibility, but it's not all, right? So I need to test some algorithms in the environment of the later topics probably, okay? Yeah, and Ziyao said that the amortized analysis is not expected to appear. You are right. So in the final exam, I will not test you on amortized analysis. That's also something for sure, all right? Now, so for final exam, it's 2 hours, right? And then you could expect that you will see, you will still see 5 questions, very likely, okay? But there will be some questions that are easier than midterm. And the difficult questions will be more difficult than midterm. And the middle range will be slightly easier than midterm. So that's the general design principle, okay? So my target for the final exam is about 70 to 75. But you know, my target has some error, right? Just like my target for midterm is 60, but maybe in the end it's 40. Well, so your estimation may not be accurate, right? So we need to look at the final average for the midterm. So yeah, so Yuqi, you're right. In the final exam, there will be only one difficult question, and this difficult question will be 25 points. Okay, so that means if you can solve all easy questions, you get 75. Then it's a sure A. No doubt. Okay. Well, but But you know, even in difficult questions, you can get some marks for simple sub-questions, just like today, right? So today, which question do you think is the most difficult? The most difficult one? Oh, 2. 2 is the most difficult one? Okay. 2 just has too many words, all right? So just like Ping Chun said, 2 just has too many words, but 2 actually is very, very, very simple. Okay. So it's indeed very simple. So, well, but your exam strategy is that it's too long, so I just skip that. But that question, now when you have time, you can read it now. So actually, this one is quite easy, and then the algorithm design part is also very easy because, well, this question is asking you to design some algorithms. It also gives you some examples, and then that DP is well, you see. Next week I will explain. Okay, today is too late. I do not want to, well, take more of your time. So next week I'm going to explain the answer. But that DP, so that DP can be considered as the easiest DP. It's on the line. It's very easy indeed. Yeah. So I do not agree that DP is never easy, but well, this one is indeed very easy. And then. Okay, and then I guess in general, now also so before I answer Ziyao's question, now which question is easiest for you? So this is also some question I would like to ask. Now for okay, yeah, sorry, second easiest, sorry, second easiest. Oh, 3. So the location game, right? Okay, yeah, nice. Actually, next week. Or maybe in the week after next, we are going to talk about the location game things. Okay. So I believe that your average could be higher than what you expected, and then I guess I will come to the yeah. So I will now. Roughly explain the schedule of the remaining weeks. Okay, so next week we'll finish fair division and explain the midterm and probably make a start for the facilitation. And then week 12 will be mainly facilitation and with some tutorial to explain some questions, some problems. All right, and last week will be scheduling. So I'm going to reduce the content I'm planning to cover for scheduling. So this is the, and also after scheduling, we'll have some the tutorial, well, problem explanation, and then let me see. There are some messages. Okay, so Zhengwei, about the sharing, right? So this is more urgent. About sharing, you are not sharing to CS Lab admin. Okay, so you're not sharing to that. To CS Lab stuff. You are sharing to my TA, okay? So please read the announcement about invigilation. You can see it there, right? Okay, and then there are 2 questions. One is for the last question, do we need to use MI? So what is MI? And then another question is about greedy. Oh, induction. Well, actually, I don't know. Maybe later on, well, so next week I'll explain. All right. Probably don't need that induction. Well, correct me if I'm wrong. My TA is also here. And video is not for submission. Okay, it's sharing. Okay, you upload to OneDrive and share. Pay attention to the announcement in Canvas. And then about greedy, so Ziya asked, the greedy algorithm seems not to be an online algorithm because it has the ability to sense the delay cost. Well, so actually it's not right because this greedy, it does not know future information. Okay, so for those packets which didn't arrive, the greedy algorithm has no idea what they are. Okay, so he only has knowledge about the already arrived packets. And then for those packets, when time moves on, the greedy algorithm can compute how much delay it has caused, right? So it is online algorithm. And then, yeah, okay, good. And then Jiang Kun asked when to release the grades of the quiz. I would expect that the grades of the quiz will be released before the, before the next lecture, so that you will know how much you get, okay, before the next lecture. So yeah, and then exam paper, about exam paper, so you cannot download again. Well, I need to do some setting, but I guess for now you don't need to download it. So maybe your concern is more about the question 2, right? You would like to take a look at question 2 to see whether it's really easy. All right. So for I can. Well, so I guess I will. Let me see. Yeah, so for that file, so you may rest for a while, and then, well, next week I will open that, or sometime later today I will try to open that, and try to do some setting. Maybe I guess a simple way is just to upload this file to some. Let me see. Let me just upload it to the files category. Yeah, so it's a midterm exam. Oh, sorry. Yeah, I corrected some typos in the midterm, so maybe it's safer for me to correct them and then upload. So I will delete it first. Yeah. Anyway, I will upload in about 10 to 20 minutes. And then there is another question about the focus of the content in the final exam, right? So for this one, well, I cannot say very clearly which question is for which topic. This is not possible, but I can narrow down. For example, I can say, now just one example, all right? I can say, oh, which lecture, some lecture, the materials in that lecture, I will not test you on that, okay? So it's something like this. Or maybe in a specific lecture, I say, oh, this part is not needed. Yeah, 关于video, I guess you cannot send it to me, right? So you need to share. But anyway, yeah. So Wenchong, yes, I will make an announcement. Actually, I will not make an announcement on that. I will review. So you remember that in week 14 we'll talk about the scheduling only for 2 hours, and in the last hour I'm going to review all the materials we have covered up to now, up to the end of semester, and also explain which part will not be required, or the other side, okay, which part will be required in the final exam. But I will not make announcement. Yes, then you have only 1 week left. It's true. So your strategy is review the materials after midterm first. In case in the last lecture, I said that some earlier things are also needed, you still have time to review. Okay? Or maybe, so actually, I remember I promised you that I will not test you on week 14 material, right? So maybe the review time could be in week 13 instead. Okay? So after I finish facility location games, I will let you know which part will be tested in the final exam. All right, so I guess that's fairer to you. Okay. So week 14 will be purely scheduling. Yeah, so as Xinjun said, right, so I will tell you what materials before the midterm to be reviewed in week 13, okay? But for now, I guess, well, you also will not spend time reviewing those given your heavy schedules or of other courses too, right? So you can just, well, take a rest. But, well, you'll be highly encouraged and advised to join the lectures because, well, especially in the later part, right? So the fair division and the facility location, there are many new interesting things, and then also the exam questions will be heavily dependent on these scenarios. So it will be good to be there, and also for the purpose of the bonus, right? And then Wing Chong asked how much percentage of the exam will be material before the midterm. Well, so this part, what I can say is that that percentage will be less than 50%. This is the only thing I can say. Okay, because well, you know, midterm covers 10 weeks, so it's fair that the 10 weeks will still contribute to about 50% in the final exam. Yeah, so that's the reason, right? Our midterm is so late. That means materials before midterm very likely will occupy at a percentage of 50. That's very, very, very possible, right? You cannot expect less. And then Guan Yu also asked, can I share with you some practice paper or question before QE? Yeah, that's possible. So actually, we have another set of exam quiz paper, which I will also release very soon. You can use that as a practice. Okay. Yeah. So by the way, I don't know. Yeah. So usually for quiz or some other occasions, my Q&A sessions are longer than expected, right? So long, we usually run far beyond 250. But remember, feel free to, but because the official session today is already over, so feel free to leave if you have other businesses. Yeah, but I will be happy to answer questions, further questions in the session. I see some more questions, like it would be great if the questions in exam are similar form to our assignment. Yeah, so you would see similar form questions, right? Just like this midterm, you will see one similar form question, and maybe for final exam, you would expect to see two, right? Yeah, and then the average expected score for the final exam is 70. Yeah, so you are right. This is my expectation, but usually, you know, my expectation may not be achieved. So you could prepare for some 60 thing also, right? So my target is 70 or 75, but probably the average will be 60 or around 60. And then OJ questions, well, yeah, so this is very important, OJ questions. OJ questions will be due in the end of next week. Okay, in the end of next week. In other words, so later this week, I'll release the assignment 3. Now, after release assignment 3, after some thinking, you may decide whether you complete the OJ or you do assignment 3. Okay? Yeah, so due time for OJ is end of next week, which is week 12. And the next question is grade threshold will be set according to overall performance or is already fixed. Well, so usually the grade threshold will be independent of your overall performance. So which means that each one of you will have an absolute grade no matter how other people perform. But there could be some exception So when those exceptions happen, then your grade will be slightly affected by other people's performance. All right, but there are many such exceptions. Well, there are quite some exceptions possible. All right, so what you can do is to truthfully exhibit your performance. Right, that's the best for you. Just like yeah. So and also, as I promised, I will adjust the difficulty level of final exam according to your performance in midterm. So the threshold are roughly decided. That is also why I say if you get a final mark of 75, you are in a sure A range. So this is something, well, some reference. Okay. Okay. Now this is a tricky question. Is the midterm as difficult as QE? So I would say that the midterm question is already reaching the level of QE for question 2 and question 5. So they are comparable. So the scope of final exam will contain knowledge of midterm, like algorithms, Nash equilibrium, cooperative games. I remember that. Okay, so this is something like now the final exam will now one thing. For example, in the final exam, very likely cooperative game will not appear. Okay. So and also now, but now there's now only a tentative thing. Is it a pity if it's not there? Well, so then you see that you have different opinions, right? Well, let's see. All right. So there are still 1 or 2 weeks to narrow down the scope. Okay, yeah. Then so maybe I just give the scope for difficult questions. For easy questions, I will not give the scope, right? Okay. Now, okay. For description of problem, whether it will be very long, in the QE exam, my answer is usually not. Okay. The question 2 in the midterm is kind of testing, all right? So usually QE questions will be short. So the problem description of QE questions will usually be at most half a page, at most, and maybe even shorter, okay? Let me see whether the next question is, the question in QE is at same level as midterm or harder. Now QE questions actually is not a single question, right? So usually for the algorithm part, there will be 2 questions, one on data structure, the other is on algorithm. So I would say that the data structure one, we didn't test data structures, well, very explicitly, but the data structure question will usually be on the easy side. Algorithm question will be slightly on the more difficult side, but it is compared. So question 2, you can consider it to be at the right level of the QE question. But well, when we explain question 2 next week, you will see actually the solution is very easy. But that will take probably the majority of the question 2 in the QE. Yeah, because you know every question has some sub questions. So we will have some easy sub questions for the algorithm question, and yeah, but the most challenging one definitely is not that easy to solve. but that's the most challenging part. And then there's another question, will we know the average score of the quiz? Yes, you will know when we finish marking. And yeah, so, and then Ping Ping asks, one page? What do you mean by one page? Not quite sure. Yeah, please be, well, make it more explicit. And then yeah, question 2 is more than one page. That's right. That's right. And then what is the expected range for B grade? Well, you could consider the average to be B grade. Okay, the average mark will be the B grade of the whole class. Now, actually, about question 2, right? Actually, it has 25 points, right? So, well, yeah, it is okay to skip that due to a long description. But well, if you can adventure something, then it's also okay to give it a try next time. Just as for example, the programming contest, usually there are very long questions, but usually the long questions are easy questions. Okay, and then another question is about the 30% will get A, 50 to 60% will get B. Yes, this is still true, right? So at most 30, okay, it's not 30, okay, it's at most 30 will get A, and then so average get B means what? Means that the average mark get B, right? So, or yeah, but average get B does not mean that we cannot have 50 to 60 B, right? So the average is a reference, and then those around average will get a B or B minus or B something, right? Okay. So that's true. There is no contradiction in the design, right? So in other words, the top 20% in the B range, in this so-called B range, will be B, or maybe 30. Okay. Any other questions? I see another one. Okay. Yeah. Yeah, and then I guess about the exams, I'm just commenting on until this point. And then, well, if you have further questions about the other aspects of the course, feel free to send me email. Yeah, and also thank you for correcting the, well, some issues in the assignment 2 questions. Assignment 3 will not be released today. It will be released within this week. It might be tomorrow or Saturday. Okay, so we need to make a suitable number of questions and also balance the difficulty of the question. All right. Okay. And then the grade, well, you mean which grade? Midterm, right? So midterm, we will finish marking hopefully before the next lecture. Grade of assignment 2 will be released first. Not necessarily. Okay, which one is released first? It depends. Okay, it depends on well, which one has higher priority. Okay, so assignment, I guess, is not so in such a hurry, right? But I guess you worry more about the midterm. Yeah, yeah. So midterm performance will affect the final exam difficulty, for sure. But assignment will not. And also for in-class exercise, part 1, I would expect to give the feedback to you next week. Okay, but that part again, I'm not marking it very, or my TA is not marking it very rigorously. Okay, so it's only a rough check. And about number of lectures, we still have 3 left. Okay, we have 3 more lectures, week 12, week 13, and week 14. There are 3 lectures. And when is in-class exercise 2 due? Okay, in-class exercise 2 will be due in the end of week 13. Okay, so it's about it is 2 weeks later, right? And then what topics will be covered in the assignment 3? So in assignment 3 we'll mainly cover 2 topics. One is fair division, the other is facility location games. So which means that when you see the assignment, some part has not been learned yet. Okay, so you have to wait until next week to have the full knowledge to do work to assignment 3. Okay, yeah, any further questions? And oh, actually, in-class exercise and assignment 3, they let me double check. Yeah, because we have some early schedule about the due date. Yeah, so actually assignment 3 you will have about less than 2 weeks, about 2 weeks to do. So its due time is earlier than in-class exercise 2 due date. I didn't, yeah, so assignment 3 actually only take 2 weeks, not 3 weeks. Okay, only 2 weeks. So I will set the deadline. You can see it on Canvas. All right, I didn't create those 2 items yet. You will see it very soon. April. Yeah, one of them is due on April 14th. The other one is due maybe on that Saturday. Okay, so April 17th. But for in-class, I think that it's flexible. But assignment, I believe we cannot make it even longer. You have to be due in mid-April. But assignment in-class 2 still has some flexibility. And the OJ is due in the end of week 12. Okay. Okay. Yeah. Any further questions? Okay, so if no further questions, then take a good rest, and then see you in the next week's lecture on Thursday. Okay, yeah. Thank you. Bye. Thank you.